webinar for energy efficiency of warehousing and retail. Today we'll be going through some basics with how the energy costs are made up in terms of how the power bills are rated on, and a little bit of opportunities of where the energy is going and how you can save some money there. Alright, so we'll kick off here. Right, so first of all, the Energy Efficiency Kilowatt Program has been organised by Regional Development Australia, and it's designed to help Far North Queensland businesses, small to medium and community organisations to help save their power. I'm your presenter for today, and my work for Tropical Energy Solutions, Regional Area Manager. Okay, so a little bit about the basics of electricity. Most people are very familiar with this, both at home and in their business setting, but they don't really have an understanding other than the what the amount due and when they have to pay by is. So just a bit of background here. The unit of power itself is measured by kilowatts, and kilowatts, 1 kilowatt is equivalent to 1,000 watts, and using that for a period of 1 hour creates 1 kilowatt hour, and that's electrical consumption over time. To demonstrate this, 100 watt light bulb, which is operated for a day, would be 1.1 of a kilowatt times 24 hours equals 2.4 kilowatts. A 2.4 kilowatt kettle or 2,400 watt kettle used 10 times a day would use 2.4 times 0.1 times 10 equals 2.4 kilowatt hours. So people often look at a kettle as being a high energy user, but even a light bulb over a long period of time will use a large amount of power. Okay, so how do we find that data? Now, specifically, we're measuring the watts of an item, and you look at the labels, and in this example, the Panasonic microwave oven has an output of 1,200 watts. Now, this labeling system will change on some devices like air conditioning, and in here what you'll see is that there is multiple readings of watts. What you're looking for is the maximum input current, and here you can see 2,750 watts, which is 2.7 kilowatts. That is the input of what that air conditioning would use if it's been used 100% of the time at 100% duty cycle. Okay, now a bit of information about the Ergon Energy tariffs. First of all, just have a look at your a bit of a breakup in terms of what's happening for your bill. You've got the due date and the pay by, but you also have a column up the top of the account number. Now, during the kilowatt program, we found many times where people have had multiple accounts where they could run single accounts, or in some cases there's been people who are paying for power that wasn't actually directly attached to their account. So always have a look at this. Also, you'll see the billing period of 92 days. This affects the size of your power bill based on how long it's been between meter reads. Obviously, the longer period, then your power bill will look higher, and that can create a bit of an artificial shock. The security deposit held is a usual thing that you see there. Down the bottom you have a bit of a graph and a daily average of your costs, including GST, and an average daily usage, and that's rated in kilowatt hours. So you can see there in the last 12 months what your typical consumption has been. You'll see a seasonal variation. You'll see there's been a slight increase from 12 months earlier. Over the side here, you've got important notes. This is quite often where you'll see estimated reads or any changes that are coming up with tariffs. And yeah, it's important to have a look and understand what it is that's actually in there. Obviously, if it's an estimated read, then you need to make sure that the next read is an accurate one. Okay, into the Ergon Energy tariffs. Here you'll see on the back of the page, you will have, this is over a change of a financial year, so there's two separate readings. There's customers on tariff 20, you have a previous reading and a current reading, which is showing you the differential of the kilowatt hours they've used, and in this period of 87 days, they've used 1,128 kilowatt hours. And then you'll see the new tariff has come into effect over a period of 5 days, and what they've done is they've used 64 kilowatts. This customer has elected to go for clean energy credits, where you pay a little bit additional, and that helps subsidise your power, the power usage that you're making, being made from clean energy. Okay, now moving through here, you've got your Ergon Energy tariffs. Now, tariffs are broken up into two main criteria, 100,000 kilowatts or less, and 100,000 kilowatts and over. So just for the purpose of 100,000 kilowatts or less, the first one is Tariff 20. In Far North Queensland, we have a lot of businesses, small businesses, that are on Tariff 20. This is the default business tariff if you're a small business. Tariff 22 is the next available tariff, and this is a time of use tariff. You'll need a digital meter, and the time of use is from 7 AM in the morning till 9 PM at night at a higher rate, and at other times at a lower rate. Now, what this does is this creates a situation where people who use a lot of power outside of hours can get it at a reduced rate, and this works well in certain environments like service stations. The other option you have is one of the first of the demand tariffs. Now, Tariff 41 has a very attractive consumption rate for kilowatt hours, but you then got charged for your peak demand, and in this case, your demand is measured at 3 periods during your monthly cycle, and it's taken as an average, and that is your rate that you will pay. So it's very, very high, and this encourages customers to reduce the amount of peak demand that they have, and they can do that by sharing the loads across a certain amount of time. Okay, in this example, we can see a service station. Now, a service station obviously has a lot of refrigeration and lighting that operates outside of those hours. So it's beneficial for that service station, using the same kilowatt comparison, the number of kilowatts per year of what it uses. It's better off for that service station to be on a time of use tariff, Tariff 22. They would save $2,034 just by being on that time of use tariff. But using that same level of consumption in an office environment, very, very similar, you'll see there that on Tariff 22 it's more expensive because they're not using the power at night, so they don't get the advantage of the cheaper power. So in this case, Tariff 20 would be better for them, and they would save $1,800 based on that. So it's not a straightforward calculation, and really each business needs to be taken as a case-by-case basis. Okay, now we look into Ergon large tariffs. There is transitional and obsolete tariffs, and the main tariffs that people will be on will be Tariff 44, 45, and 46. These all have a very attractive low kilowatt hour consumption rate, but then you are slugged with a very high kilowatt demand rate. So this is your peak demand. For example, if all your air conditioning turns on at 8 o'clock in the morning and your power spikes up to 100 kilowatts at that particular time, then you will be charged 100 kilowatts throughout that month. That's what Ergon has to supply. You'll also know a significant difference in these tariffs with the service fees, and it's important to note that there's not much you can do about the service fees, but these do have a big factor. The other thing is the minimum usage, or the threshold for these tariffs. So Tariff 44 has a 30 kilowatt threshold, which means that even if you only use 20 kilowatts, you'll be charged a minimum of 30 kilowatts. And the same for Tariff 46. The same applies for 400 kilowatts. If you only used a peak demand of 300 kilowatts, then you would still be charged that 400 kilowatts as a minimum. Okay, roadmap to energy efficiency. What we found is there's a lot of noise about energy efficiency and things that you should do coming from various different sources and retailers. We found that creating a bit of a roadmap was better for people to have a start and an end point for energy efficiency in the course they go through. Okay, so the first one is one of the simplest ones, and it's tariff optimization. This can be implemented immediately, can be done as a desktop study, and the cost is typically very, very small with a high payback period if you're on the wrong tariff. There's plenty of cases where we found savings for people that have been on the wrong tariff, most of them into the thousands of dollars of the savings had they have changed their tariffs earlier. This is something that will help many businesses making sure that they're on the right tariff, and as their business changes and grows or reduces, then check again that you're on the right tariff. Okay, the next option is generation through solar or hydro, possibly wind. You may have access to a power purchase agreement through your supplier, but that usually requires a large amount of power going back to your energy retailer. You'll be able to see that there's various different sizes for PV systems, and the payback periods of these relate to how well the systems are matched. Okay, energy audits. Now, energy audits can be done in many different versions. There's a lot of information online. A lot of people will do just normal turn light switches off and air conditioning and so forth. The kilowatt program, we have proper auditing assessors that will come to site, and they do a full review, either a level 1 or a level 2 audit, and follow up with a report, and that then gives you all the information of where your energy opportunity savings are and what you need to do about it. Also includes some information about return on investment, which is handy. A lot of the information we get is based around changes of people's patterns, not necessarily massive capital investments. The next area is putting the report or putting your energy audit into place and to implementing it. So these are the energy saving initiatives that you would put into it. So it may be things like replacing old fridges with more energy efficient fridges, changing your air conditioning system to a more efficient inverter style air conditioning system, and sealing up the building, and it could be changing to LED lighting. The next area, which is very, very important, is training and communication. And this is culture in a business, making sure that everybody understands that any savings they make will have a direct saving impact for the business. So $1,000 that can be saved on a power bill is $1,000 that goes back on the bottom line of the business. And it's important that that relates from upper management all the way down. Measurement and verification. This is a service not everybody knows about. This is basically allows customers to just check that the power they're using is actually what they're being billed for. So this is checking the meters and so forth. But also just where their peak demand and high-level power usage has been used. A lot of demand-based customers will use this as a tool to make changes within their business. There's various different levels of this measurement and verification, up to the full Ergon certified classification. Ongoing energy management practices. So this is just ensuring that you've done the implementation, you've done a bit of a cultural change, but just as an ongoing thing that it's actually kept up. And this can go right through to the procurement process, making sure that when items are purchased, such as pumps, that we take into account the cost of ownership, not just the actual saving of a couple of $100 on that pump because it was on special. And water pumps is certainly a good example where if you spend a little bit more, you get a good benefit from it. Okay, we go on to building efficiencies. And tropical environments need tropical buildings. Typically, older buildings have not been designed around the environment and therefore cost a lot to light and to keep to a comfortable temperature. The first thing is to minimize external heat loads and maximize any shading. So this is going to stop the sun from heating up the inside of the building. So consider the thermal mass effects, which means the materials that the building is made out of, and minimize the internal heat loads, the heat loads that have to be removed, normally by air conditioning or natural ventilation if you have that opportunity. Maximize natural ventilation. We'll go into that in a minute. Okay, on the external heat loads, we have a unique situation in the far north Queensland where in the winter periods the sun is in the northern hemisphere going from east to west, and in the summer periods during the wet season it's actually in the southern hemisphere. Now what this does, it creates a situation where shading is needed on all four sides of a building, otherwise it's affected by the heat. Okay, now this is an example of where shading has a dramatic impact. We've got two slides here. The one on the left is a lot of thermal load coming through that window, so the sun is shining directly through the window. This business has made a big effort to drop the blinds down, even stack books up against the window. You still see that the sun's reaching down onto the floor, and it will start heating up that concrete pad, creates a big thermal mass effect, and that carries on radiating heat even when the sun is not shining through the window. The difference in temperature between a window, in this example, in the shade and in the sun is 30 degrees. So just by having that in the shade, there's a 30-degree difference of the temperature that's coming into that room. So it does make a significant difference. Your shading options for what you have, of course, is vegetation, awnings, eaves, neighbouring buildings, and screens. And those screens can be both internal and external. External work better, but a lot of people opt for the internal ones for aesthetic reasons. Insulation options is reflective roof paint, reflective window coatings, so the likes of tinting, window blinds, external and internal, foil insulation in walls and ceilings, and bulk insulation in walls, ceilings, and in some cases floors. High thermal mass materials. High thermal mass materials are solid objects. So you think of concrete, stone, brick, tiles. These are good for maintaining the temperature where there is a big day-night variation, permanently shaded locations, or slowing down daytime temperatures to allow the building to maintain a temperature. They're not good where you don't have a big differential between day-night temperatures, so the building doesn't get to cool down quickly, and areas that are exposed to direct sunlight, because they create a lot of heat, they generate a lot of heat, and then they will carry on emitting that heat even after the sunlight is there. Buildings with high internal heat loads, there's no advantage having a high thermal mass building, and the other problem is that high thermal mass buildings maintain heat radiation well after sunset, and you'll see this in restaurants that operate in the evening, but they have to run a lot of air conditioning because of the thermal mass build-up. Low thermal mass material is where you would have timber frames, aerated concrete, or composites like freezer panels. We're starting to see smart, energy-efficient buildings using these smart composites to reduce some of their heat loads. These are good for buildings that are exposed to a lot of heat, air-conditioned buildings, and they respond quickly to change of temperature because they have that level of insulation between the inside and the outside temperature. They're not good for storing cool or heated air in a building, because they will change temperature quite rapidly. Two forms of ventilation: natural ventilation, cross-flow ventilation, where you'll open doors or windows on one side, and then you'll have an area where the doors and windows are open on the other side. You get a nice breeze going through there. That obviously depends on the season, location, buildings around you, and so forth. The other option is natural draft ventilation. You'll see this in anti-termite mounds, but this can be demonstrated through whirlybirds, where you see a whirlybird on the roof of a commercial building, totally passive device, and it will be spinning away as the hot air is convecting up through the central ceiling cavity and causing an exhaust of the hot air. What it does, the added benefit from that, is not only removing the hot air, but in that process of removing air, it replaces it normally with the cooler air from outside, particularly if you can take it from the shaded side of the building. Okay, so saving opportunities. Big one with air warehousing is, depending on the type of warehousing, air conditioning, which would normally be in the office area, refrigeration, if there's refrigerated logistics involved, lighting is a big one, office equipment, and water heating. Air conditioning in the tropics. So the big thing with air conditioning in the tropics is the type, the age, and the size. So basically, is the air conditioning unit suitable for the application that it's been used? Then, has it actually been put in the correct place? Quite often businesses will change from the air conditioning unit that was put there 10 years ago. There may have been 3 or 4 different changes of business. So it's important that it is matched with its purpose that it's designed for. The main thing with air conditioning is to reduce the duty cycle, how hard the unit has to work to maintain a temperature. So reducing your external heat gain and reducing your internal heat sources are going to help the duty cycle of the air conditioning unit a lot. Stop cool air losses, so opening doors, gaps in windows, all these things that will allow hot air to come in and the cool air to go out, and nobody likes to pay for excess air conditioning. Natural ventilation, this may not always be available, especially in the wet season. However, if you can hold off turning the air conditioning on for at least an hour or a couple of hours in the morning just by having nice ventilation coming through there, that's certainly going to make a big difference to your power bill costs. The other area is behaviour. in terms of making sure people are vigilant about closing windows and doors, setting the temperatures to make sure that it's comfortable but not necessarily very, very cold. Okay, we can see an example here just where some air conditioning units have been installed on a roof. It looks very aesthetically pleasing. However, you'll notice that basically the outdoor units, which are designed to remove cool air, they're actually in direct sunlight, and they're blowing, as they're removing the hot air, they're blowing it directly into the next unit across from it. So from that point of view, not a good way to remove a lot of heat from these units. In the far north, we see a lot of insulation breakdown. This is often not picked up in maintenance checks, and it's important to make sure that your air conditioning company does actually check the quality and the condition of your insulation for your refrigeration lines. Okay, speaking of refrigeration, again, is it fit for purpose? So we look at the age of the units. There's been a lot of advances that have happened in air conditioning and refrigeration in the last 5 to 10 years. These are also units that will degrade over time in their efficiency, that what they were once efficient, now seals don't work as well. There may be moisture in the insulation, which makes it null and void. It's important that you keep freezers in particular defrosted. If there's a lot of frosting going on, it's usually a sign of leaking seals and trapped air coming in that it shouldn't be, and the condenser is having to work a lot harder to try and reach its specific set temperature. So defrosting will make a fridge work or freezer work a lot harder than it needs to. Also consider the number of units. If you've got 5 fridges running doing the job where you can do it with 3, you're paying for that additional power, for those additional area, the cubic area of those fridges to cool particular things down to a point. Location, keep them away from heat, and make sure that they're well insulated. And the same applies for cool rooms. Okay, lighting. Lighting is a big one. There's been a lot of advancements. People think that compact fluoros are energy efficient. Compact fluoro technology has been out just over 24 years, and there hasn't been many changes. There's been a few changes in how the switching and the starting happens with them, but essentially they're still the same equipment. The latest advancement has been LED, which is now becoming very cost effective, but needs to be looked at in a case-by-case basis. Obviously the best way is free lighting, and if you've got a source of natural lighting through skylights or windows, then that certainly should be looked at as a long-term saving opportunity. The builder's approach is they need to consider what the level of lighting that is required. Quite often we'll see large warehouses or storerooms which have very, very high light levels, which are not needed. This process is called delamping, and it can be just a case of removing 10, 20, sometimes 30% of the actual lights, still to achieve the same result, but just to get an instant saving. Switches and sensors. This is important, particularly with outdoor lighting. Daylight sensors. This removes the human error factor in terms of people forgetting to turn lights on, turn lights off, and that's also important. There is a standard of lighting levels, AS and NZS 168.12006, and this will tell you what your requirements are in specific areas from car parks through full lighting, office lighting. Okay, so there's many different options in terms of how the lighting can be used, and we see people using a lot of innovation in terms of natural lighting as well. Office equipment. This is important. On a warehousing situation, the office is normally quite a high energy user because of the equipment that's inside it. All of the equipment inside produces heat. If it's been operated, the air conditioning then has to work against that heat to try and cool the office down again. So remove any obsolete equipment that you've got. If you've got 5 printers that aren't necessarily needed, you can unplug these. Unplug the ones that are not needed. They will be consuming power even in standby mode. They'll also be producing a little bit of heat. Not always practical, but notebooks use roughly about 1/3 of the power of what a desktop does. So this is important when you look at it from an energy efficiency point of view, also from the heat emission that comes out of that. Purchase criteria, again, this comes back down to what your replacement policy is when an item does die, like a printer. Look at the energy saving side of it. The small saving that you can make at the time of purchase can be well outweighed by the operational cost ongoing. Okay, water heating. Water heating, there's many options with water heating, from evacuated tube to gas to heat pump, right down to just the simple electrical element version. Again, this is something that has to be suited, fit for purpose. So the size, the age, and the number is important. We see a lot of businesses that are running multiple hot water units where they could actually just have one or two. If you're heating up water that is not needed, you're paying for that unnecessary heating. The consumption, basically match your hot water system to the amount of hot water that you need. The general rule of thumb is that you will turn your temperature down just enough to meet the requirements of the business. Now, obviously, this change is different from an office environment to a camping ground, but yes, you don't need to have 60 degrees coming out of from a 200-litre hot water tank if you've just got a small office with a sink. And consider what the alternatives are in terms of zips and urns, or evacuated tube. So, appliances and tooling. In warehousing, you may have various different appliances. Consider the size of the appliances. There may be a tendency for people to oversize equipment that they need to allow for future expansion. That does come at a cost, and just to understand that, what is the cost benefit for that. The type of appliances that you choose. Again, look at whether you've got small equipment that is working very, very hard and having to have a very high service life, or whether you can actually match the unit for its purpose. Gas versus electric. There is good examples where gas, particularly in the heating, is more efficient than traditional electrical heating. Consider the location of what these appliances may be, and the operational changes within your business and how they match to those appliances that you've got running. This also applies with compressors. Compressors work a lot harder when you have a lot of heat being produced, and they lose their level of efficiency. Okay, but at the end of the day, every journey starts with a single step. Your step today has been to listen to the webinar. I hope you found it informative. Every company's journey is different, and you may have already put some things in place to help saving take place. But the savings that you can pull back on your power, these are the things that will give you a competitive edge, particularly if your competitors have not made these energy savings. Every dollar saved in power is a dollar that gets put back into the bottom line of the business. So if you can reduce your energy costs for 20%, then that 20% goes directly back on your bottom line. So good luck. We're available on the 1300 number or the Kilowatt website, and we look forward to hearing from you soon. I hope this has been useful. Thank you.